Well, good morning, everybody, and welcome to HMV News Live, a webinar with our friends from Daikin, and it's all about IAQ. For this morning, we're going to have a couple of presentations, and we will also have some panel discussions. We can't have a panel discussion without questions from the audience, so I invite you to use the Q&A button to submit your questions. From experience, we've learned that you should not press return too often in your question. Keep them short and keep them on one sentence. Otherwise, you end up firing 4 or 5 parts of one question. Don't use the chat function for questions, please, because that confuses things. And I'll be doing my best while chairing to ask your questions in an informal way. So don't be too upset if the exact wording does not come across. We will create a debate. That's the idea. We've got some excellent speakers today from Daikin, and I'm delighted to introduce our first speaker to give us an overview, and that's Dr. Veena Kakadia. So over to you, Veena.
Thank you, Andrew. Thank you for that warm welcome. Thank you for inviting me to present today. It's a real pleasure to be here to give almost like an overview of this very, very complex topic, which is very close to my heart. So just a tiny bit of background on myself. I'm currently Research Development Manager at the University of Surrey for the Global Centre for Air Pollution Research. But prior to that, I spent 25 years or so working at the Building Research Establishment, where I successfully established and developed and managed the research and scientific direction of BRE's air quality, air pollution area and that business, both for industry and government. So So this is my presentation today, looking at good indoor air quality for occupant health, well-being, comfort and productivity. Can everybody see that?
Not yet, Veena.
Okay, it's not.
There we go. Now that's in presenter mode. So there we go. All good, Veena.
Thank you. Okay, so my presentation today will be on looking at good indoor air quality for occupant health, well-being and comfort and productivity. Now, as I said a couple of minutes ago, it's a very, very complex topic, a topic that's been close to my heart for many, many years. So without further ado, let me just get on with it. You don't need to take notes because I think the presentation will be available and it's very self-explanatory. So just sit back and enjoy. So my presentation will consist of looking at a little bit about background of the air pollution in the UK, looking at outdoor pollution to begin with, why various concerns as to why is indoor air quality important, what the impact it has on both cognitive function and productivity, so in other words, health, and also business operating costs, why it isn't adequately addressed at the current moment, looking at the different sources and how they impact the indoor environment, and then how we can achieve good indoor air quality. Finally, summarizing with a short summary. Okay, so we all know that increasing population and human activities have led to increases in air pollution, both outdoors and indoors. In the UK, exposure to air pollution causes between 28,000 and 36,000 deaths a year from a number of heart-related diseases, lung cancer, pneumonia, respiratory infections, all sorts of infections. And I put at the end, there is a slide with all the different references on, so you will be able to look up, the source for this information. But looking at just London alone, nearly 9,500 people die each year as a result of air pollution. But we're also it's costing the NHS, over 20 billion pounds every year in health costs. But we've also got now growing evidence that impacts on mental health, in particular depression, bipolar disorder, personality disorder, and those sort of things. And there are papers and references that you can go and read at the end. I think many of you may have seen this in the in the local news, or in the news generally in the UK, where a 9-year-old girl, Ella, was basically she already had asthma, but they reckon that air pollution in her area, high levels of nitrogen dioxide, actually affected her lungs and her health. And basically, the Southwark Coroner's Court found that the air pollution made a material contribution to Ella's death. So I think that really brings it home to us as to why air pollution, air quality is really, really important, and why it's important to reduce air pollution in our environment, both outdoors and indoors. It's not moving forward. Okay. So air pollution in the UK, it also impacts both the outdoor environment, not just health, but also ecosystems and buildings. So you can see some of these statues where corrosion has happened due to the effects of air pollution. Now, to date, outdoor air quality or air pollution is regulated quite highly, and various initiatives are in place to reduce the air pollution. But there could be many years before the quality of the air will be deemed acceptable. Now that then leads to the potential for outdoor air pollution to ingress into the indoor environment, where we spend a lot of our time. Essentially, we spend at least 80 to 90% of our time indoors. And as you all know, in the last couple of years, due to COVID, we've spent pretty much all of our time indoors. And even the healthy people have been spending more time indoors. But when you're the infants, elderly, the people that are not so well, they're spending more and more time indoors. And it's so important to ensure that the indoor air quality is good, as it can have an adverse impact on their health, comfort, both physical and mental health and well-being, performance and productivity of workers. I mean, we're also now finding that there's a lot more sick leave and absenteeism because people are falling ill with not very good indoor air quality. We're doing a lot of this work around schools, indoor air quality in schools, and also how outdoor pollution affects indoor environment, because it's actually affecting learning ability and cognitive behavior, healing and recuperation. And as I said earlier, it's affecting building structures and materials. So it is extremely important to reduce the ingress of outdoor pollution into the indoor environment, as well as the indoor environment where occupant exposure is likely to be very high. So just some studies carried out by Alan in 2016, Alan and his colleagues investigated the association of cognitive function scores with carbon dioxide and volatile organic compounds and fresh air. So fresh air ventilation is really regarded as air that is fresh or uncontaminated with pollutants. Now, in places like London, that's probably not the case, but the building regulations stipulate that the air must be fresh when it comes indoors. So that's something that we need to consider. But the study found that when CO2 concentrations increased to levels that are common in indoor spaces, so above or around 950 ppm, cognitive function scores declined significantly. Now, just going one step across from that, now that we've got COVID to also consider, COVID-19, or respiratory infections and those sort of things, viral infections to consider, there has been recent work going on which has claimed that we need to bring the limit down to around 800 ppm. So enough ventilation to ensure that CO2 levels are lower or within 800 ppm to ensure that, we're not affected health-wise as well as cognitive function-wise. It also found that CO2 and VOCs at levels found in normal conventional office buildings resulted in lower cognitive function scores, but increasing the fresh air ventilation lowered the exposure to CO2 and VOCs and other indoor contaminants as well, which then resulted in increased cognitive function scores. So that actually shows that good indoor air quality is extremely vital for the health, well-being, comfort and productivity of the occupants. Now, there aren't any similar studies at the current time on NO2 and particles and their effect on productivity and cognitive function, although studies are ongoing, but there's nothing published at present. Looking at typical business operating costs, research has shown that in terms of its operational cost, energy consumption amounts to only about 1%. Rental costs account for about 9%, but staff costs account for 90%. And now that is including not just salaries and sick pay and so on, but also physical and mental health problems. And air quality is, part of that. And also indoor air quality is going forward is likely to further contribute to the staff costs. It can also lead to increasing number of occupant complaints, which is happening now more and more as people become more aware of their indoor environment, increased business costs from reduced staff performance, high cost to the health system, higher costs for operation and remediation of buildings due to the damage it causes, and reduced market and rental value of buildings. So as a result, investors, owners, managers are now increasingly demanding high quality indoor environments with good indoor air quality. Certainly when I was working at BRE, I carried out quite a lot of consultancy work where people, investors were particularly worried about their buildings. So we carried out a lot of indoor air quality assessments. So why isn't indoor air quality dealt with effectively? One of the main reasons is that there's a lack of research and understanding of the complex interactions between outdoor pollution, indoor air quality, and numerous variables. Whilst there has been research carried out and there is some guidance out there, there are still many, many gaps that still exist in the detailed knowledge. But things like the actual pollutant source, the type, where it's located, what are the surrounding buildings, local topography, dispersion processes, for example, in an urban area, they're going to be extremely complex. So if we just look at the figure at the bottom there, this is a generic urban area where we've carried out wind tunnel studies. You see that there's a point source there. Now, if you were an architect, for example, or if I was an architect personally, I would automatically assume that I would need to put ventilation inlet on the other side of the source, other side of the building to the source to prevent any ingress of pollution. However, our studies have shown that this is the dispersion pattern that occurs. So pollution actually rises up on the leeward side of the building. So that would actually be the wrong place to put it. So these are some of the parameters that need to be taken account of. From some of our initial studies, we have produced some guidance, ventilation of healthy buildings and reducing the impact of urban air pollution, and also location of ventilation inlets. And there are methodologies in these documents, but there is a lack of new updated practical guidance that's at present, which with research addressing gaps in knowledge and that produces an integrated approach to designing buildings, taking account of outdoor indoor pollution, ventilation, and all other associated parameters. And that has been leading to inappropriately designed buildings. And I'll just give you one example of that. Now, we have many from our studies. Often issues are not adequately addressed. So things like, for example, location of inlets and exhausts are not appropriately located, so you get cross-contamination issues. So if you see this picture, we've got some gas boiler flues And under certain wind conditions, you're likely to get ingress into the air handling unit. So anything that's been emitted from these boiler flues are going to go straight back in to the system. Now, we have carried out studies where it shows that NO2, for example, has gone straight back into the system and dispersed throughout the building, and NO2 levels within the building have been quite high. Indoor air quality is becoming a very, very important part of the building design process now. And local authorities are looking for that, especially with their planning process. But as you can see, it's a complex area, and it's therefore a real challenge for building professionals in designing and operating buildings effectively. Okay, looks like this diagram looks quite complex, but it just shows typical pollutants that ingress from the outdoor environment and all those sort of pollutants that you have emitted in the indoor environment. And it all depends on the environment that you're considering. So for example, a home will have different pollutants compared with a school or an office building. And there is a document that's available, which there is a reference at the end. And in fact, I've put the reference at the bottom here, which explains some of these pollutants and where they're actually, what their sources are. This diagram shows, similar to the other one, it shows the actual sources of the different pollutants. This presentation will be made available, so you can actually look at it in more detail later. So this is the document I've just been talking about. It's one of the first ones that was produced about 3 years ago, and it actually details air pollutants and their sources, the impact it has on indoor air quality and health, well-being and productivity. There's a lot more detail in there. Typical indoor air quality standards and guidelines that we can use at the moment, whilst there isn't anything more formal. Some strategies on how to improve indoor air quality and some case studies. This is all based on information that was available 3 years ago. So let's give some strategies for achieving optimum indoor air quality. So you've got outdoor air pollutant sources. I will cover the right-hand side, which will be the indoor air pollutant sources. So outdoor air pollutant sources gives you poor indoor air quality. So potentially, what are the mitigation strategies that we can use for the outdoor air? The first one is source control. And that always has to be the first port of call, is source control. So, for example, looking at outdoor pollutants and their emissions, such as vehicles and industrial sources, these are already controlled by various legislation and regulation and guidance. For example, the blue document there, which was written back in '93, for which I was one of the authors as well, is looks at guidelines on discharge stack heights for polluting emissions. So for industrial processes, it deals with how to disperse your pollutants or the pollutants that are coming out from stacks effectively so that they don't affect the pedestrian level height, so at ground level. Despite all these various regulation in place, outdoor air pollution levels are still very high in the UK and are likely to remain so, at least in the near future. So additional measures are required to reduce those and also to reduce their ingress. And the sort of strategies I'm talking about are things like effective location of ventilation inlets and effective filtration systems. And I think one of those air purifiers is becoming, a lot more important now as well in the indoor environment. Just to show one of the major discoveries or innovative strategies that have taken place recently, and the University of Surrey in the GCare team has pioneered this work since 2014, is green infrastructure. So they're looking at plants and plant-based structures, green walls and green roofs, and actually validating some of the findings. So they're finding that vegetation can act as a barrier between the pollutant source and receptor, but it also depends on the species type, the planting configuration and management. We have produced some simple guidance on implementing GI, and it is available free of charge on our website. So if anybody's interested, please do contact me and I'll give you the details. And we are also carrying out a lot more work currently around schools and seeing how vegetation can help reduce exposure to air pollution, outdoor air pollution, reduce it ingressing into the indoor environment and affecting indoor exposure as well. We've produced a tool. It's an interactive tool, computerized tool that helps users to design their own hedges and barriers against traffic-related air pollution. So you can actually go, it's a very, very simple tool. So you can go into the tool and based on where you live, you can actually work out what type of hedge to plant outside your house if you wish to, for example. We've also been carrying out lots of school helping to mitigate exposure to traffic pollution in and around schools, and we've got some guidance that was produced last year. This has now been translated into 12 languages, I think, across the world, and it's being used in 12 countries across the world as well. And more countries are obtaining copies to translate them into their own languages. So it's a really important document that's come out in recent times. So the next one is looking at air tightness and intake, location and control. Many of you may have seen this document written by BRE on air tightness in commercial and public buildings. Air tightness, many people don't understand exactly what air tightness is. It's really adventitious gaps and cracks in the building envelope that allows uncontrolled infiltration into the indoor environment. So with the fresh air or with the air outside comes the pollutants as well. Obviously there is some deposition through the building fabric, but if they're very fine particles or very fine or gaseous, they'll go straight through. So it is important to seal the building envelope and then increase its air tightness and reduce contaminated air ingress. And the logo that we normally use is, build tight, ventilate right. So once your building is airtight, then you bring in air from an appropriate clean air part of the building and ventilate the building. So according to the building regs, air permeability should not exceed a limiting or worst allowable value of 10 meters cubed per hour per meter squared at 50 pascals when measured. And to satisfy energy and acceptable CO2 emissions, air permeability may typically be of the order of 5. So that's very, very low air permeability. So going on, just wanted to show you a case study. This is a building that I've been part of and I monitored many years ago. And it's a typical building that we still have problems, these sort of problems in current buildings. And that's why I like to put this slide up. It's a naturally ventilated daycare centre with sealed facades located on a busy high street. There's a bus stop right in front of one of the offices. The sealed unopenable windows on the roadside, but the ventilation comes from the garden courtyard side, which is shown in this picture here. So the courtyard offices are ventilated via openable windows on this side, but these are the ventilation intake ducts for ventilation of the offices on the other side, the roadside side of the building. However, in principle, in theory, it was designed effectively, but then in operation, they converted the courtyard into a car park. So during rush hour, when the cars were coming in the morning and going out in the evenings, the engines were revving up, so pollution straight into the ducts. Not only that, because it was a daycare centre, some of the staff used to get stressed because it was a mental daycare centre. They would stand outside here and smoke. So all the smoke was going straight back into the building. Inside the building, where they had ventilation ducts, extract grills, they covered them up to prevent drafts. So basically it made the ventilation strategy completely ineffective. So these are some of the issues that we need to look out for when we are designing buildings and when we're operating buildings. So going on to approve location of ventilation inlets, I won't go through this in too much detail, but information is out there. Essentially in document F, part Appendix D, that was a new section that was put in the year 2010. I made sure that that went in there so that the location of the ventilation inlets was actually considered. So they obviously need to be away from local sources. They mustn't be placed in courtyards. And if they are, then there must not be any pollution discharged there, as my previous example showed. At the roof level, cross-contamination between exhaust stack and boiler flues must be avoided. And during short local pollution episodes, we could try fully recirculated air, which may be used from the atria as a source of fresh air. The other one is filtration. I'm not going to say very much about filtration, except to say that mechanical ventilation systems use filtration. It's not my expertise, but we will have a presentation on that. So I think I'll skip over that one. So going on to indoor sources, essentially, I'm going to cover the whole lot in one go: source control, ventilation, recirculation, filtration stroke air purifiers. So indoor air pollution source control basically means that we need to avoid polluting activities or keep them to a minimum. And this is something that essentially in domestic places, we do need to educate everyone to try and reduce, the use of candles or incense sticks or perfumes and those sort of in sprays and those sort of items. No smoking. Electric is probably better than gas cooking, and the use of low emission materials and products. Now, the UK building regulations state that the need for a complementary strategy of source control by reducing the release of VOCs into the indoor air from building components is really, really important. Also, extract ventilation, recirculation of ventilation as well, and the use of filtration air purifiers. So this is the latest. After my colleague and I produced the first information document in 2019, since then we've also produced a document which covers various aspects of indoor air quality in the environmental scientists, and these are all freely available. And recently the Institute of Air Quality Management has actually produced indoor air quality guidance, assessment, monitoring, modeling, and mitigation. They've actually produced a methodology for assessing indoor air quality and then finding a method to reduce the levels of indoor pollution, so reduce exposure. So these are hot off the press, and I suggest that anyone that's interested obtains a copy of these. So if we deal with the outdoor air and the indoor air, then hopefully we'll get optimum indoor air quality for both health, well-being, comfort, and productivity. So finally, in summary, achieving good indoor air quality is absolutely important for health, well-being, and productivity. Investors are now demanding good indoor air quality, and this is high on their agenda. Indoor air quality is extremely complex and depends on both outdoor and indoor pollutant sources and various other parameters. Ensuring adequate, effective ventilation is essential. Some guidance now exists. However, more in-depth research and understanding is still required, especially in terms of solutions for reducing exposure. And one of the most important things is to provide an integrated approach to designing buildings, taking all the various parameters into account to give good quality indoor air. So just one slide on the work that we're doing at the Global Centre for Clean Air Research. Our vision is to realise the collaborative global vision of clean air for all. And by understanding the impact of air pollutants on life quality, developing internationally validated engineering-driven solutions, and underpinning regulatory strategies. So with that, it covers a whole host of things. If those people are interested, please do visit our website, because we are working with people like yourselves to come up with solutions and testing and validating the equipment. So thank you very much for listening, and if you've got any questions, I'm sure we can address those.
Thank you, Veena. There's certainly a big subject, isn't it? And it's great to have your expertise giving us the overview. You're going to start with a few questions, but we're going to introduce a panel. So the way this is going to work, we're going to have a short panel discussion now to discuss some of the questions that have come up. Then we'll have another presentation, and then we'll return to the panel. So I'm going to introduce Cliff Jones and Matteo Dall'Ombra from Daikin, and Peter Reuter from AAF International. And we will introduce them in a minute. We'll just make sure they're all there. And first of all, I'm going to fire a couple of questions at you, Veena. This question comes up every time, but it's a good one to tackle. So you mentioned outdoor, I think you mentioned fresh air, and the discussion is fresh air or outdoor air. Are they not very different things these days?
Well, fresh air, when the building regulations were written, you know, they've got fresh air. And when I first started working in this area, I used to think fresh air isn't fresh air, it's actually outdoor air. So it should really be changed, that terminology. I mean, perhaps in rural areas, you might want to call it fresh air, but even then you've got pollen, all sorts of contaminants that affect people. So it isn't really fresh air at all. It is contaminated air. So outdoor air, whatever that may be. So you're absolutely right, Andrew, there.
This is, I think it just shows, doesn't it, that it's a subject that is very easily, there's a lot of written information, but some of it has now been overtaken by events. And I know that people listening in are, you know, they're concerned with how COVID is changing the landscape. Shall we let's have a bit of panel introduction.
If I can just add to that,
yes,
I remember when I first started in this area, I spoke to a colleague at DEFRA. It was DETR at the time. And, you know, we were both in the air quality area, and she basically said, we're sorting out the outdoor air. What's the problem? You know, no problem in ingress. And that was 25 years ago. And it's to be the same discussions coming back again and again and again.
I guess one of the things we're going to try and get to grips with as a panel is how can the HVAC sector, you talked about collaborative working at the end, so it's if we could come up with no better solution at the end, but how can we work better together? That would be a great solution. Right, let's get the panel talking. So do you want to start with let's start with Matteo. So Matteo, tell us about your experience here.
Morning everyone, and thanks for having us today. So my name is Matteo Dall'Ombra. As Andrew said, I'm from Daikin, UK, and I specifically look after VRV products for Daikin. So we're talking about all sort of medium to large type of commercial applications, and also in some areas, some higher end residential application as well, do sometimes for within sort of that product. And certainly because of the type of product I'm looking after, so that VRV type of products, indoor air quality, it's becoming, of course, a major topic for us, because we're talking about, for example, large offices, we're talking about retail applications. So lots of applications where you have many people concentrated together. So the way that you deal and you treat the air within those spaces is, of course, critical. So certainly, and you will see later on during my presentation how we try always as much as possible to come up with as many solutions as we can to have as positive effect as possible on the air that we treat with our systems.
Thank you. How about we go to Peter next?
Yes, good morning. My name is Peter Ruiter. I'm working for AAF, which is like part of Daikin Industry. And I'm there the director of filtration technology. So I'm a sort of specialist in filters. You know, I'm heavily involved with Eurovent. I'm involved in, you know, like mirror committees and air filtration and filters, and also all the filters that goes into the air handling unit. Which you need to create like a, you know, like a healthy indoor environment, so to say.
Thank you. And Cliff?
Good morning, everyone. So Cliff Jones, I'm the Applied Business Manager in Daikin Air Conditioning UK, looking after a range of chillers, heat pumps, air handling units, and fan coil units. And those ranges are supported by a specialist applications team around the UK, really tailoring the units to ensure that we put the right options onto the units depending on the applications, be it a commercial type process or an industrial type process. Speaking more specifically about indoor air quality, that would relate largely to our air handling unit ranges, in which we would tailor the ranges based on some of the filters that AAF provide to the group. So depending on what sort of quality or level of filtration you would need to achieve a better indoor air quality.
Thank you, Cliff. So we've got questions flooding in, which is as expected. Let's tackle these in some groups. So are air purifiers the answer, or is it effective ventilation? We've talked in the past over how the market for air purifiers has exploded. But is the answer just to have good ventilation, or can air purifiers help? I don't know whether you want to tackle that one, Veena, or Peter.
I think, if I may jump in, just to start a conversation, I think it's never either or. It's probably going to be a combination of the two, and there's a combination, maybe even a sort of additional solutions. Because at the end of the day, and also as sort of mentioned in the presentation, and what I'll sort of we'll see as well later on, is always a combination of the air outside, but also the air inside. So you need to make sure that you're properly dealing with both sides of the equations. And at the end of the day, if you deploy multiple measures, you can only sort of compound the positive effects. So it certainly doesn't hurt in that way.
If I can just add to that, I absolutely agree with Matteo on that. It's a combination of both, but I think we also require more research on air purifiers just to see how effective they are. And I'm saying that because we are actually testing some air purifiers in schools at the moment. As we speak, we've got a few schools in London where we're looking at how air purifiers will improve the indoor air quality there. So yeah, it's a combination of both. But remembering that, which gaseous pollutants are we dealing with as well, and what are the actual emissions? So it's a whole host of things. It's not just particles, for example, or aerosols that we're dealing with.
Yeah, if I like as an add-on on the remark, we did, as AEF, already done some studies, like on with these air purifiers and how do they help. And we did this with the University of Karlsruhe in Germany, where we placed some, some air cleaners inside the room, conference room, and then we had some sources, like inside. And and our conclusion was sort of, if you have like like a ventilation degree of 4 to 6, with the air cleaner, the air quality in the room significantly improves. So when you are somewhere between 4 and 6, because the idea is, like you can have an air handling unit installation, or you don't have an installation, or you don't have any place. Like if you got a, like an air cleaner, you can just like slide it in the room, you put a plug in and it's running. So, like if you don't have anything, it's an easy fix, so to say. Like in all fairness, my daughter has an allergy, like for pollen in the summer. And I've got one in her room. You know, I just put it on before she goes to sleep, and she sleeps like like easy, because it works for allergies as well.
I think just the sheer proliferation of air purifiers has muddied the waters a bit for the consumer. Again, this is it's an HVAC audience, so I think part of our role as the industry is to guide people through the what should we say? Guide people through the labyrinth of claims, counterclaims, regulations, and standards. On which note, one of our audience has said, you haven't mentioned TR19 compliance, which is cleaning of the ventilation system. Should cleaning and disinfection not be part of the strategy for better indoor air quality?
Absolutely, it should be. But as I said at the beginning, it's an overview, and there's so much I could have covered. So yeah, absolutely, it should.
We could have given you an hour, Vina.
One of the things that I did say, that it has to be an integrated approach. So we have to consider all the different aspects. I did write a document, wow, it's 2004, where I said that in order to have good air quality indoor and outdoor, we need to bring all the different aspects together into an integrated approach. And the Institute of Air Quality Management has tried to do a little bit of that in their new document. But what they've done is they've brought various aspects together. And again, the people that wrote that document didn't fully understand. There isn't that much understanding out there. So what I did was I commented on the document, because we had lots of people, it went out to review, and we've commented on it, and they've taken all our comments on board, and they've actually produced a pretty amazing document. And all the information that's relevant is in one place now for the moment, until something else comes along. So I do suggest that, people get that, because it's got all those aspects in there. All those different documents are important.
Is that one of the documents that you referenced on the last page of your
presentation? Yes.
That's good.
I mean, if anybody, I can send an email with all the relevant ones to Daikin, and they can pass it on as well.
Yeah, I think one of the things that we do after these webinars is we try and circulate to the audience all the relevant materials, so we can do a big bundle of that. That'll be great. Okay, a couple more questions, and then we'll go to the next presentation, but there will be time for more questions later. There are a couple along the same lines. Should we expect similar legal exposure limits to IAQ as we've seen from the World Health Organization for outdoor air quality? Should we expect those? Are they coming? Or are they here? I think they're here, aren't they?
They're not here.
Okay.
The document that was produced was based on the information currently available. And in the absence of anything else, those are the limits that we are using already. So in some of my documents I produced, I can't believe I produced some of these documents 5-10 years ago, and they're all very, very relevant and current. I refer to those guidelines. And then for certain pollutants where guidelines aren't available, the way what I recommended is that we use the HSE exposure limits in EH40, which you may know of, and divide those, because those are meant to be for the healthy population, fully healthy population, the working population. So what I've done is you divide it by a certain number. It's all in the guidance. You divide it by a certain number, which will then bring it down to a lower limit for anybody, for the general populace. And then that's what we would need to follow. So there is guidance out there, but there's no actual formal guidance to say these are the indoor air quality guidelines, full stop.
It's often the public and those who serve them often want something that's a number, makes life a lot simpler, but it's not always possible with the way that guidance is drawn up. There's a point being made here. You mentioned recirculation of air. In these days of COVID-19, any variants, recirculation is not a good idea. Indoor disinfection and high levels of filtration should be the way forward. I don't know what you think about that, but that's a question. I said that.
It looks like I overlooked that, didn't I, in my presentation? Yeah. Whoever wrote that question, they are absolutely right. We do need to find different ways now and research is being carried out across the world, actually. And maybe in another event, I can bring some of that research together, because we're looking at ventilation in all sorts of areas. And certainly Kathy Noakes is one of the top researchers that's actually working in that area, in ventilation area. And the
on that, sorry, who's?
Sorry, no, I just wanted to add on the let's say the topic of recirculation in general, sort of working with the air which is already inside the building. Again, one of the many things that we focus a lot of attention on in the last few years now is how we can sort of have a positive effect on that front, and also, so essentially, how can we enhance an HVA system with all sort of different measures that can sort of, again, have a positive effect on the indoor air quality in areas where maybe you are not able to bring a lot of fresh airs, or even in areas where, and finding ways to upgrade existing systems. Because one of the other things that we cannot really forget about is that sometimes when we talk about this type of system, it's way easier to have this type of discussion if it's a brand new building where you have lots of time to plan in advance, make sure that you design it properly. But as I said, we cannot forget about the fact that there are many systems out there which have been running for many years, and they're not certainly due for a complete redo. And so it was also important for us to find ways to upgrade those existing systems to provide those positive solutions as well.
I think there's interesting points being made actually on the wires at the moment, which is there's a big difference, big distinction should be made between existing buildings and new buildings, because at the way things are written at the moment is, I mean, it's not all simple, but when I say it's simpler to write good IAQ design into new buildings, it's harder and harder to get people to pay to retrofit. There's questions about financial support. There's questions about let's just talk very briefly about financial support, then we'll throw over to Matteo to do his presentation, because we will answer these questions, but I'm just trying to manage it all. Is there financial support for IAQ, and should there be? Who wants to answer that one? I know what the answer to the second one is. That's yes, but is there currently?
Okay, so let me just go from my experiences.
Okay.
Obviously, the answer is yes. It's more crucial now than it's ever been, to do this research and find the right solutions, affordable solutions, especially in the home. I remember over the years, it's not considered at all, or it hasn't been in the past. And in fact, I remember when Wembley Stadium was being built or being demolished at the time, we were looking at pollution from construction. So one of the initial guidance I wrote was on pollution, reducing pollution from construction. And they came to us as the experts at the time to monitor the site over the period of its demolition and construction. And when we put in it was, for 18 months of monitoring, wasn't particularly a high sum, but they hadn't got that money on a multi-billion pound project. They didn't have a few $100,000 to put out to give us to do that monitoring. And that was purely because they hadn't budgeted for it.
Yeah.
So, that's where it needs to come in. It needs to come in right at the beginning. If you're going to put in a ventilation system, it's got to consider indoor air quality for the people, because up until now, it's considered the quality of the system, so it doesn't get damaged or clogged up and so on and so forth, but not the indoor air quality. Because I worked with HVAC colleagues at BRE, and they didn't really have much to do with myself until I came in and really said, look, we need to think about the air in the space, not just in the system. And then we worked together so every project we did, we made sure both aspects were covered.
Collaboration. So back to collaboration again, Vina. Very good point made by one of the audience is, so should we be pressing the government for clean air grants alongside the ones that are being offered for low carbon heating? And the renewables. It's clean air. it's shifting the focus a little bit from just reducing the carbon and decarbonisation to reducing the carbon and improving the air quality. It's there's a lot of work to be done in the corridors of power, I think. Right, on that note, I'm going to pass out. So thank you, panel, for the first foray. We're going to now pass over to Matteo to offer the second presentation, and then we'll all reconvene for more questions. So thank you so far, and over to you, Matteo.
Thank you. Share my screen. There we go. So hopefully you should all be able to see my screen now.
Yeah, it's all good.
Perfect. So part of my presentation is essentially building up from the discussion that we just had so far, and just give you an idea of, in terms of when we talk about the actual equipment, what are some of the options that you may be able to consider, again, in order to provide that great indoor air quality control within sort of buildings. So as we've seen already, as we discussed already, there's no doubt that sort of indoor quality and especially air pollution now, it's, I mean, it's been an issue for many, many years. And I think what we are now seeing essentially is just that it suddenly went from the back of our mind to the front of our mind, unfortunately, due to the last couple of years and the pandemic and all the discussion that were brought from there. It's not a problem that was just born now. It's just something that I think we are now collectively as society sort of spending much more sort of brain power on and brain time on. And one of the other things to consider is that we shouldn't just talk about the sort of health aspect, but also from a building point of view, there's also the sort of the maintenance aspect and the management aspect of the building, that if sort of the indoor quality and sort of a good approach to ventilation design, if they're not really done in a proper way, then you're just going to face increased costs and sort of potentially more downtime for your system. So there's lots of infrastructure issues that also need to be considered when we talk about indoor air quality in general. As we already seen in the first presentation said, and as we have discussed, whenever we talk about indoor air quality, we cannot just talk about outside or inside. It must be a combination of the outside and the inside, because at the end of the day, if there is poor air outside and you have a ventilation system bringing in fresh air, you are actually potentially bringing more issue into the building. And then, of course, once you're looking at the inside part of that equation, is how do we deal with what is already inside? How can we either take it outside or deal with it in other ways? But certainly it must be a combination of both. So whenever systems are deployed, they must be deployed with that optics of dealing with the two sides of the building. Now, of course, we've been talking a lot about sort of ventilations, the idea of try to replace the indoor air, the stale indoor air, with fresh air coming from outside. But one of the unique sort of elements of sort of HVAC systems, and especially from a Daikin point of view, having such a wide portfolio of options, is the many, many different options that we can have to manage and treat that air that we are taking in. Again, to make sure that once it comes in in a controlled way. So it's not just shoved in without any control, but there's actually sort of some control applied on it, again, in terms of delivering not just great indoor quality, but also, especially when we talk about application where there's lots of people inside, is also a level of comfort that you need to bring to the occupants. Because again, it's not just bringing air in, but how you sort of bring the air in, or how you replace and you treat the air which is already inside the building. And so it's really key from a system design point of view to make all of those considerations. And so you see how the problem becomes increasingly more and more complex, because suddenly there are so many different factors that you need to consider to deploy a system with high level of efficacy. And again, here's where we can sort of help in some way, between sort of the availability of the products, but also the expertise over many, many years of design and how to deploy this type of solutions onto the field. Of course, as we all know, and again, as we partly discussed already, there's lots of regulations that sort of we need to consider when we do sort of design of ventilation systems. First and foremost, when we talk about building regulations and Part F, but then on top of that, there's also many different resources that we can find around, related to sort of giving example on good design, good practices, elements to consider and keep in mind when doing sort of design of ventilation systems. So there's a plethora of documentation out there, and more sort of is being created, is being refined, and it's being changed with the times. So it's really important to use those resources, to make the most out of those resources, again, to make sure that whatever system you end up designing at the end of the day can fit the purpose as best as possible. Now, from a Daikin point of view, as I said, I think we are in a very unique place because of the wide range of products that we can offer that can be deployed on many different type of applications, from a very small scale to a very, very large scales. And again, products, accessories, combination of different solutions that together, when deployed together, can overall have a great positive impact on the air management and the air treatment inside the space. So just to give you some examples, we can do centralized ventilations, and certainly Cliff can give us a better review and can answer also the question around that front if you have any. We can then instead offer decentralized solutions, so in the form of modular L or VAM units. And so here you can already see, depending on the size of the building, depending on the type of flexibility and the type of local control that you want to have, there's many different solutions that you can deploy. And of course, each has its own benefits at the end of the day. But then, as I said, on top of that, and as I mentioned in some of the answer that we gave earlier during the first panel, it's not just about the system itself, but it's also, and especially if we're talking about an existing system where you may already have some of the solution deployed on the field, it can now become a question on how can I upgrade my existing system? What can I do to improve an existing system? Because maybe it's just recently been installed, but or anyway, it's still sort of well within the lifetime of such a system. So it's certainly not due for a complete replacement. So how can you take things to the next level? And again, here is where, again, I think we are in a slightly unique position where we can offer lots of different options. So for example, we do have, as you can see here on the slide, we do have a couple of solutions for automatic clean filters. So we do have this solution for our ducted units, which is the module that you see here on the slide. Or we've had this module for our run flow cassettes for many, many years now. Conceptually the same, just different shapes, of course, to fit the various type of units. But the idea is that at least the basic, one of the sort of the basic action that you can take is making sure that the filters within your indoor units are as clean as possible at all times. Because yes, filters are there to catch particles, dust, all sort of components up to certain sizes, of course, depending on the grain of the filter. And certainly some of the basic filters are doing a basic action, as you would expect. But at some point, if this filter becomes too clogged, too dusty, then of course their efficacy sort of dies down, and then you end up actually spreading whatever should have been catch, actually sort of start making its way through into the space, into the room. And of course, this would give a massive negative impact on the indoor quality. So one of the first sort of tips that we normally give is that always make sure that you run with clean filters. And of course, we know that it's not always easy, practical, because you may have many of these deployed on the field. Some of them might be installed in very weird spaces, despite sort of all the guidelines from a service point of view. So that's why we have deployed this type of solution where you literally have a self-cleaning filter. So there's a small cleaning robot that periodically goes over the filter, cleans it, collects the dust, making sure that the filter is always free of these buildup of particles, so it maintains the efficacy over time. And again, these can be deployed fairly easily as upgrade on existing systems. Then, of course, we do have optional filters. And now even more that we're tightening our partnership and our relationship with AAF. There's all sort of different grades, different shape, different applications of filters that can be deployed on a variety of, again, systems, both centralized and decentralized. And again, that could be seen as a second step in terms of how you can increase the usefulness of HVAC systems when it comes to indoor air quality. And then we do have sort of built-in features like flash streamers, which again are a solution that are deployed in wall-mounted units. These typically are more reserved for residential applications, so the type of splits that you would put in your home office, your bedrooms, that kind of applications, where again, with those specific sort of filters built in and solution, again, like the flash streamer relying on ionizations, again, we can provide a great level of indoor quality. We can make sure that the air in the space it's clean, and again, we can overall deliver a positive effect on the space. Now, as I just mentioned, of course, and especially now in these times where the conversation around indoor quality, as I was saying, went from the back of our mind to the front of our mind, we know that sort of we even have a higher responsibility in try and deliver this type of solution and give the market as many options as we can in order to positively affect the indoor air quality. So essentially what we've done in the background in the last year or so is that we went out, scoured the market, and tried to find partnership and solution that we could deliver together with our products, again, in order to make sure that we could have great indoor quality. And as we said before, it was a case of how can we deliver those partnerships for both new, but also especially renovation projects, because as I mentioned already, we cannot just focus on new buildings where it's fairly easy, or let's say it's easier to account for this solution. Whereas on existing installation, again, you may have all sort of constraints, budget, space. And so we wanted to find a solution that could apply easily to both cases so that we can truly sort of give something to every possible application out there in the market. So what we've done is that we came up with two partnerships. So these two solutions, they're not Daikin own developed solution, but we created a partnership with third party in order to make sure that we could still deliver a plug and play type of application when it comes to deploying these two solutions onto our units. So as you can see on the slide, we do have UVC solutions, so UV tubes, and also plasma ionizations accessories. So the UV tube, these are sort of provided onto the market in a partnership with Eco, who is a UK distributor of a US manufacturer of UVC tubes. And so by having sort of created this partnership, essentially we can provide all of the bits and pieces needed for the kit, so that when, if you want to deploy it on our ducted units, it's really a plug and play solution. So it's just a case of mounting a plenum on the supply side of the ducted unit that will house all those components needed for the UVC treatment, and just power supply, and you're in business, you're ready to go. As I said, the solution for ducted unit is the plug and play solution, but we can also offer it as a more bespoke solution. For example, if you want to do it, if you want to deploy Similar technology maybe on larger centralized plants, so for HUs, or even on van type of units, so in decentralized applications. So we will have a solution for those. And then the other one is the plasma ionization accessory. So again, here we created a partnership with the UK distributor of Plasma Air, who is the actual sort of manufacturer of this technology. And plasma ionization, as you can see here, relies just on this very sort of fairly small module that you can easily house inside pretty much every single indoor units that we provide. And so this can be a very easy, cost-effective, and again, quick solution, especially for retrofit installations, and especially where you have that type of sort of decentralized and spread around systems where you might have many fine coils around your space. Then you can really target every single area in your applications. And so just to give you an overview in terms of where you can deploy these two solutions, as I said, the UVC solution intended as a plug and play is for our range of ducted units, so for both slim and standard ducted units. And then instead you can see Plasma Air, it's everywhere else. So pretty much every single other indoor unit that we offer can be fitted with these solutions. And you will see for both options, you will have the possibility, for example, for us to pre-fit either one of these adapters before the units are shipped on site, for example, or, as I said, especially if you're looking at these to upgrade existing installation, we can just deliver the different adapters and then you can fit them yourselves, for example. And the good thing is that sort of both of these solutions, as you can see, they can be applied to our entire portfolio of commercial and sort of small, medium, and large commercial applications, so SCADA, VRV systems, any type of refrigerants. So really, we wanted to cover every single unit that we offer, so that we knew we could deliver a great solution. And with that, I'll thank you very much for your time and attention. And I think we can go back to our panel to have further discussion on this topic. So thank you very much.
Thank you, Matteo. Yes, let's reconvene the panel. We've got questions outstanding and questions to continue. We've got about 20 minutes, so plenty of time to follow more of these questions up. What I should have said at the beginning, my head is darting about from side to side because I can't see the questions on my small screen because I'm too old for that now. So that's what I'm doing. I'm not checking out what's going on somewhere else. Maintenance. This is one for the Daikin crew. Maintenance has come up several times in the questions. Do you have a requirement for maintenance once you've fitted the systems? If not, should there be? And then one for debate is, should there be more of a legal requirement for maintenance? Because several of our questioners have said they've gone into buildings, found that in some occasions, no maintenance has been done on things like fan core units or duct or cleaning of the ducts. What's your view on this? So, Cliff, do you wanna do this one?
Yeah, I think definitely. I hear what listeners are saying in terms of maintenance. We see so many sites where the maintenance is exceptionally poor. Yet sometimes the maintenance records have even been signed off. And I think there needs to be more legislation put in place, and probably COVID is going to highlight the need to put that legislation in place, especially when it comes to ventilation systems. I mean, as a manufacturer, we've got a prescribed maintenance regime on all products, and that will be seasonal maintenances and major visits, minor visits that we prescribe. But I think when it comes to indoor air quality, maintenance can also be subjective to the area that you're in. So the frequency in which you clean filters might be very dependent on the outdoor air quality that you're drawing into the system. So I think it's not a one way suits all. So you need to actually look at it dependent on the site. And I think Peter can probably add more to that comment in terms of maintenance of filters.
Peter.
Yeah, yeah, we have the same experience, like in AAF. We do have recommendations in place, like for a first stage filter and a second stage filter. It's the dualism of the filter. Like you capture like a lot of dust, but the air is also going through the dust. I always give the example, like when I spill my coffee and I vacuum cleaning, and the next day my wife puts on the vacuum cleaner and I can smell the coffee. So you don't want to have that in your handling unit. You don't want to have that smell. So even though like the filter is not on the end of its capacity, so because you're measuring the delta P around it, it does make sense to sort of replace the filters like regularly, and you need to inspect it. Nowadays we try to help our customers, like to putting sensors in place, because you can do like a lot of things with your iPhones nowadays. You can get like sensors in place, so that we start what I can see in the world of today, we start more and more with monitoring, so that we can see what the condition is, like the same as in your car. So you don't go to the garage because you've driven 30,000 miles, but you're going to the garage because your car is saying to you that you need to go. So I think we will move into that. We're not there yet, so to say, but we will come to there, like in the next. It will be a focus in the next couple of years, I think, so that monitoring will help us in selecting the filters and determining our change out.
I think the rise of monitoring systems is certainly going to draw attention to the air quality issues. But Daikin folk, you probably have some means of alerting when a filter is ready to change in some of your systems, no doubt.
Yeah, absolutely. Most of our system, you can actually set, and it's actually preset for the unit, what would be the frequency for the cleaning and also the useful lifetime of the filter. This is a fairly basic function which has been built in for now many years. And even, for example, with the solution that I mentioned, the auto cleaning solutions, that you will also, of course, get the option to change the frequency of the cleaning. Again, as Cliff mentioned, very much depending on where these units are deployed, because they may require a very different regime of cleaning. And of course, you will get all sort of alerts when it's time to then empty the dust collector section. So yes, absolutely, monitoring and that kind of sensor and reaction to how the system is working, it's there, absolutely.
Thank you.
Maybe just to add, there is also an ERP requirement in which you need to be giving a visual alarm when filters need changing.
Okay.
So that's a fairly recent requirement. I think it came in 2018. Again, I think also in this day and age with the Internet of Things, more and more products are being connected to the web, and there's the possibility to remote monitor products. So I think this is the future that we'll see, whereby we are able to get the indications on the kit that we've got deployed out in the field.
Do you envisage that being the contractor that does the remote monitoring, Cliff, or is that a manufacturer doing the remote monitoring?
There's lots of different models. Some of the models could be manufacturer-led, some of them could be contractor-led. I think the models that we look at, mainly it's contractor-led initially, whereby they've got access to the equipment in the field, and they can do their troubleshooting from remotely before actually sending operatives out to site. I think the manufacturer level is there in case we would need to interrogate units further.
Yeah. Okay, good, thanks. Okay, got a very specific question that has got probably a one-word answer, which is the plasma add-on available on wall mounts?
So it's not available in the form of the external adapter that I showed toward the end of my presentation, mostly because it physically wouldn't fit in the wall-mounted unit, because is always to keep the overall compact of the unit as small as possible. Then sort of everything is very, very tight. But having said that, on some of our split units, wherever you see the flash streamer option, well, which is actually a built-in option, so it's not anything that you need to add, that works on a very similar principle. So it is available on essentially already as a feature, as a built-in feature for some of our ranges. But as always, we'll be looking at trying and expanding as much as we can wherever it's possible.
I think one of the challenges, as we're illustrating, is that there's lots of different technologies, and even the add-ons have different names, and it's part of the challenge is to convey that the end result will be just as good with a different name. So we now have to bring the flash streamer into common vocabulary, along with plasma, which is just starting to gain traction. Here's a question which I don't know whether it's going to have a definitive answer, but it's a good one. Going to throw this to Vina. Air purification or UV, which is the best option?
The simple answer is I have no idea.
Good. I was hoping you wouldn't give a definitive answer one way or the other, because that would only cause more discussion.
All I can say is, test both, and we need to validate which one is better.
Has there been
for different applications, you probably use different.
Yeah, I was going to say horses for courses. Has the proliferation of technologies that's caused a challenge for researchers, hasn't it? And just there's so much to try and get across and validate. Yes, it has.
But one of the things that we're finding is that there are so many new initiatives or new areas for research that are more important, that some of the research areas that we feel are important are just not being funded. With COVID coming on board, everything is just being thrown at COVID. So
we as in AF, we did, if I want to add on, if I may add on, we did some research on it, like in the old days, everything, on bacteria and viruses was always HEPA filtration, and HEPA filtration is like 100%, it's it really works. So you got efficiency of 99.999, so like many nines, so you can basically state that nothing comes through. So if you got a virus, just sit behind the HEPA and you're okay. So with a UV light, you got the intensity, but you got a wider spread. And sometimes you cannot install a HEPA. If you got like an existing airline unit, you can't fit a HEPA, and then the UV light might cover a complete ceiling by spreading out, these lights. And when you do it in the airline unit where you don't have the HEPA and you got like a high intensity, it will work as well. So, it's not like, one is better than the other. The question is, the plasma sort of deactivates the viruses, the HEPA captures it, and then the virus is inactivated in time, so to say. So both work absolutely all right, but there are complete different applications. So if you go to your hospital, you're laying on your back, you're getting on surgery and looking upstairs, there you see the HEPA, because then you can't work with the light because it needs to be low. But in an airline unit, it works magnificent. So depends a bit.
I think it very much underlines that it's important to have expert advice. So talk to your supplier, talk to your contract. I mean, I'll do the advert for you. Talk to your supplier, talk to your contractor. And also, I think another key area which we shouldn't forget is the FM, the facilities manager or the building manager, has a very important part to play. And I think with some of those folk, it's an education process, because this is all certainly the whole COVID regime has come up fast for these building managers. So I think a lot of it is about advice, and it's about hand holding, and it's about making things making the research available and helping them make the right decision. Here's an interesting question. Do you think that recirculating system should now be phased out, made illegal, whatever you want to say, because it should have a fresh air element. Somebody says they keep going into new buildings and finding recirculating air when rather than the fresh air input switched on. Who wants to tackle that one? No.
Yeah.
Okay, go, Peter.
Oh, sorry. Like I was too eager.
No, carry on.
Yeah, no, like when we look like 5 or 10 years back, you know, like we were making the buildings as close as possible, because, you know, like we needed to comply to the heat exchange, that you don't lose like a lot of heat. So you need to be like in compliance to your energy qualification. You need to recirculate. You know, like, and we're now forgetting, you know, like, so to say, in this discussion, that there are like new methods. So if you look at, and Daikin also, what Matthias showed you, we got like beautiful heat exchange systems. So, you know, what you're doing with recirculation of the air is you don't want to use the energy, what you got like inside, the conditioning, the heat and the humidity. So you don't want to easily blow it outside. But when you got an office building, and when you're just blowing the air, you know, like to the outside, but when you use a cross system and you take the energy out, you can go over to 100% air. So the newer systems, you know, like from Daikin, will help you with a big deal in just getting this recirculation out, and then working with outdoor air and taking the energy out of the recirculation air.
Thank you. Here's an interesting one. I've got, sorry, Vina, you come in there?
Yeah, I was just going to add to that and say, well, I think it also depends on what type of building we're looking at. I mean, if there's a really, really tall atrium, would we still then, you know, recommend recirculation or not? I mean, some of these are the issues that we need to consider, because, you know, we have to have that balance between energy consumption and indoor air quality, air tightness, and everything else, fresh air. So, yeah, I think it also depends on the type of indoor environment that we're looking at. Obviously, in homes, it's more difficult. It's not probably advisable to have recirculation. But if you've got a building, an office building with a tall atrium, where the air at the top is most likely to be fresher, it's all relative at the end of the day. It's worth thinking about.
Thank you. A simple question, this, is there guidance on the minimum number of air changes per hour that are advisable depending on the premises?
I think, yeah, there's quite a lot of guidance. I mean, there is the Part F building regulations, which stipulate the required air changes. Obviously, COVID has brought about a lot of discussion around those air changes and whether they need to be updated. But as we stand today, they're not currently updated. I mean, there is, on the main guidance, which is 10 litres per second per person, is whether that needs to be increased to 15 litres per second per person. But then it's not clear as to whether you're taking into account a lower population density within the environments based on social distancing, which could mean you're still at 10 litres per second on a normal population density. So it's horses for courses at the moment. And yeah, I think we do need clear guidance as to where we are going in the future in terms of ventilation design, because going from 10 litres per second to 15 litres per second will have a big impact on the size of the units, the size of the ducting that needs to go into the buildings. So there are also going to be practical challenges with it. And it's finding the balance on those practical challenges, the additional consumption on energy, before I think the industry will be at a point where they can give a clear number to us and what that number relates to.
I think, again, that illustrates that the consumer, or in this case, the operator, wants a simple number. Just give us one number, but it's not as simple as that. It is, as you say, the phrase that keeps coming back, horses for courses, it's application specific, isn't it? And again, you need to have advice from your expert. We have just 4 or 5 minutes left. I'm going to give you a couple more direct questions, and I'm going to ask my usual roundup question. And so to flag up for all of you, so you can be thinking of it, it's going to be, what one thing should the audience take away from today. So somebody has called in from Poland and said, what is a healthier alternative to wearing a face mask so as not to inhale a large amount of carbon dioxide? So one of you Daikin folk will probably say, well, it depends, any of our options. I guess that's what you're saying, isn't it, Matteo? Is now you have available a suite of options that can help with indoor air quality.
Yes, that's true. I'm just I'm not entirely sure how to make the connection between that point and sort of the use of face masks, because I guess they are very different and sort of would be deployed for very different reasons. But yeah, as you were saying, we are trying as much as we can to bring as many options as possible, or rethink the way that we deploy, design, and apply our existing product, just so that we can sort of deliver sort of the best mix of indoor quality as possible. And that's at the end of the day just the general Daikin philosophy, if you wish, that whenever we provide a solution onto the market, it always must create some positive benefit and some positive effect for the entire for all the stakeholders. So not just whoever installs it, but the building owner, whoever is going to be within the building. So there must be something positive for each of those. So yeah, that's how we normally operate, I would say.
Thank you. Okay, so one more question, and then we'll go to that roundup. What is the opinion of the panel on heat recovery ventilation? Does the heat recovery aspect have a bearing on IAQ?
No, I think it's a must in terms of energy efficiency of systems. Whenever you're introducing large amounts of fresh air into a building, you need to have heat recovery on those systems. And that is also a legal requirement. Once you've got more than 10% fresh air over the air that you're supplying into a building, you should have heat recovery.
Excellent, thank you, Cliff. Just one, I'm going to throw one more comment in, which is somebody saying, surely the air quality should be judged on the measured air quality rather than simply on the measured fresh air flow rate. And I guess the answer is both is important, isn't it?
Absolutely. Like I said, it's that integrated approach. You have to look at all those aspects.
So let's go to that roundup question. I'm going to throw in the fact, I don't know whether any of you is going to mention this, but from the audience reaction, they want everybody to note that maintenance should be a key element. You can have all the whizzy new stuff in the world, but if you don't maintain it properly and clean it properly, it doesn't continue to operate at optimum for air quality. So yeah, the audience says, don't forget maintenance. So let's start with, I have you in a sort of clock face in front of me. So let's start with Cliff. What's the one thing to take away from today? You want the audience to take away, should I say?
Really, the importance of ventilating. I see so many premises which aren't ventilated, and this could be high street coffee shops, it could be offices. Ventilation is an important part, and it's part of the building regulations. So to create better indoor environments, we need to be ventilating.
Thank you, Cliff. Peter.
Yeah, you know, like a lot of what I see nowadays, that a lot of people are like nervous for, you know, like for COVID, and you know, like, and they have questions what to do, and you know, like, can I improve my ventilation? And sometimes that's difficult. Sometimes you don't have the availability of an air cleaner. And then my advice would be just open the window. Research has shown that, you know, like ventilation is key. And if you got nothing available, you know, then just open the window. It's not always possible. Sometimes it's too cold. Sometimes you get a smell in, but even the smell will not have the COVID inside.
Thank you. Veena.
Could just say all of the above, couldn't I?
Oh, no, you're not allowed to say that. You have to add one as well.
I would say I would say we need an integrated approach so that we, like you said, we consider all the aspects, so outdoor pollution, indoor air quality, ventilation is a key part, air tightness, maintenance, absolutely. And I'm glad the audience have put that forward, because one of the things I didn't mention is post-occupancy evaluation, because things change. Once the building has been occupied, systems are not used very well, or maintenance isn't carried out, and that is absolutely the key. So yeah, it's an integrated approach.
Thank you. And Matteo?
I think probably to stop, think, and really consider what the problem is, because many times now we just see someone wants to quickly react because everybody's just talking about indoor air quality and this problem. But I think it's really think about what your building is, what your needs are, and then go and find the best solution, not just the first that you find, but the best that would actually suit your application, your building, or whatever application you're considering.
Thank you. Well, thanks to the panel, excellent discussion. Thanks to the presenters for excellent and informative presentation. Thanks to Daikin for sponsoring this and allowing us to put on such a webinar. The HMV News Live webinar brand is available to anybody who wants to take part. So thank you very much. Thank you to the audience for your interesting questions. As we usually do with webinars, we will put a digest of this webinar up online on hvmplus.co.uk. We will then, within a couple of days, put a recording up, and we will be circulating a package of materials, including the presentations and the links, to all who are registered. So thank you very much for taking part, and we'll see you again soon. Thank you. Goodbye.
Thank you.
Thank you, everyone.